Hello everybody and welcome to another Mystery Box Function Challenge. In the purple box there is some mystery math and your challenge is to figure out what that is. Today is a Friday and so this math in the purple box is going to be even more challenging than usual. If you'd like to try this out, use the link in the description, and when you get an idea, come on back, see if we get the same thing. All right, let's start with 0. Oh, and here we got that negative infinity. So recently we had a logarithmic graph, and it gave us that same negative infinity error. That can also pop up in rational functions. So let's try some negative values maybe. So this is making me think that it's a logarithmic function because those negative values aren't defined for the logarithmic function. So let's try putting in some positive values. How about a 1? Okay, 1 gives us 1. How about a 2? Okay. I'm going to jump right to 10 because I'm wondering if this is a log base 10 or some other type of log. So let's put in a 10. Oh, that gives me 11. Huh. Let's try some other powers of 10. I'm going to do a 1/10. That's interesting too. Actually, this won't be, maybe won't be on the graph. Well, of course it won't be on the graph, but let's put in 100. What? 102. So because I'm getting all of these nice round numbers when I put in powers of 10, I think this is a log base 10 of x. But something else is going on. And I think maybe the approach I'm going to take is look at what I would expect to get and then see what the difference is and try to sort it out that way. So remember, with logarithmic expressions, they're kind of a rewriting of an exponential expression. So if you had some base and you raised it to the power a and you got the result c, the way we think about that with logs is the log of that base, you take that of that result, you're going to get the power that you raised it to. So for example, the log base 10 of 10 is going to be 1, but we got 11. I'm just going to put a 1 here because that's what I would expect to get if it's just the log of x. The log base 10 of 1 should be 0. Why? Because anything raised to the 0 power is 1. So if you've got a log base 10 of 1, it should equal 0, and we got a 1. And let's try 100. I think this is going to be the easiest way to sort this one out. So the log base 10 of 100, what power do you raise the base 10 to get 100? It's a 2. So we expected a 2 and we got 102. So what is going on here? When it was 0, we added 1. When it was 1, we added 10. So this is plus 10, this is plus 1, this is, and when we expected 2, we got 102, so that's plus 100. It looks like we're always adding the input back in. So I guess that would just be the log of x plus x. I mean, we can try that with 1,000, right? The log base 10 of 1,000 should be 3. So it should be 1,003 for a result. And we could try it with, let's see, 1/100th. 1/100th should be negative 2. But we add we add in that 1/100th and we get negative 1.99. So I think we've actually got this. Let's take a look. Whoops. Let's take a look. Let's get rid of that pen. There we go. So there it is, the log of x plus x. And let's graph that as well. It's a strange looking one. Yeah, so here it does look like a logarithmic function. It has that line rapidly shooting down next to the y-axis down to negative infinity. But then it basically becomes this line y equals x. So it looks like this part of the function for the first little bit, and then this part of the function on after that. All right, well, how did that go for you? I think that was super tricky. But let me know. Thanks, everybody.